Example 10, we're going to look at this question. An angle of elevation of a tower from point A, 72 degrees. From point B, 50 meters away from the tower. Then A, the angle of elevation is 47. So we have to draw a diagram. So let's draw a tower. There's a tower. And the angle of elevation from a point A, which is over here, we assume that the tower has to be vertical, otherwise you will fall down 90 degrees to the ground. The angle of elevation is 47 degrees. No, or 72. 72 degrees. And then from point B, which is 50 meters further away than point A, that's 50 meters, you get point B. The angle of elevation becomes smaller as you expect as you get further away from the target. We're going to find the exact length of AT. Now T, I think, is the top of the tower. Yeah, T. Okay, so we're going to find the exact length of AT, which is this length. So I can use a highlighter. Alright, we're going to find out what this length is. So we have to use one of the rules. So there are three triangles you can use. There's this right angle triangle, the small one. And there's a bigger right angle triangle. Or you can use the non-right angle triangle. Now, the question is, which triangle should I use to find the length of AT? Well, the next question is, which triangle has the most information? So which triangle has a side length given? AB, yes. So AB belongs to which triangle? ABT. So we should use the non-right angle triangle because it has more information. So what we do is we're going to use this triangle. May draw this again. So you got the 47 degrees. Alright, so we'll draw this again. So we have the 47 degrees there. There's a B, there's a T, there's an A. Now, how do we find this angle, which is this angle A here? Alright, how do we find? So, yeah, it's 180 minus 72. So if you 180 minus 72, which is 108, which is over here, we've got the 50 degrees there, 50 meters. So we're going to find the length of AT. And think about what rule should we use, sine rule or cosine rule? Sine rule because it's not SAS nor SSS, so we're going to sine rule. But before we do that, we do need to find a missing angle over here. To find that missing angle, you have to subtract 180 by these two. So 47 plus 108, so get a calculator. You need to have a calculator ready for this exercise, so you do 180 minus 108 minus 47. Yep, 25 degrees. So 25 degrees, we're now ready to use the sine rule. Okay, so to use the sine rule to find AT, now remember you have to find the exact length. Exact, what does exact means? Means AT over sine of 47 equals to another side, which is 50, over sine of the angle opposite. And to find AT, actually you don't need a calculator because they want exact. They do not want you to press the button on a calculator because it gives you a decimal. So you just leave your answer like that. That's like your exact answer. Okay? Exact answer. Okay, good. Alright, so the hard part is to draw the diagram. The next hard part is to actually work out which triangle to use, which can be tricky, but the decision can be made based on the fact that this triangle has more information because it has a side length given, whereas the other two triangles, both right angle triangle, has no side given. Okay? Alright, good. Once we do that, we can find the height of the tower, which we're going to indicated by H. Now, if we're going to find the height of the tower again, you have to ask yourself the question, which triangle should we use? Now, remember, we've got the length of AT now, so which triangle would be the most appropriate to find the height? Well, there's two choices. You can use the big triangle or the small right angle triangle. Which one will be more appropriate? The small one, because I got the highlighted length given, right? We got the length, which is 80. So we use the small right angle triangle to work out the height. Let me draw this over here again. There's a H there, right angle, and that angle is 72. This length of AT is now given to be 50 sine 47 over sine 25. Remember the exact length. Okay? You don't calculate it yet. So we're going to find the length of H. So what you do is you write H over AT. This time we don't use sine rule or cosine rule. It's a right angle triangle, so we use the SOHCAHTOA. In this case, opposite over hypotenuse is sine. So write sine 72. Like that. And to work out the height, you do H equal to AT times sine 72. Now you know why we don't find the exact length of AT. The exact length of AT is just this, right? So just replace AT by 50 sine 47 over sine 25. And then multiply by sine 72. So this is like an exam type question where they get you to find the length of one side and use it to find the length of the other side. That's like an exam type question. So what you do is you can use a calculator to work out what it is, correct to one decimal place. So do 50 times by sine 47 times by sine 72 and divided by sine 25. 82.29. Correct to one decimal place, 82.3 meters. That's the height of the tower. Okay, any questions? And then one more problem to solve, then you can start the exercise after this. Yep, finish. Yep. No, one more page. Huh? Yeah. Alright, one more page. Listen carefully. Shh. Next one is bearing. Bearing can be a bit tricky, so pay full attention. Bearing. A ship sails from Sydney for 200 kilometers on a bearing of 40 degrees and then sails on a bearing of 157 for 345 kilometers. How far from Sydney is the ship? Okay, let's draw the diagram one by one. Let's draw the first bit. It says a ship sails for Sydney 200 kilometers on a bearing of 40. So you start that's your destination. That's your starting point. And from the starting point, what you do is you draw a cross. That's how bearing works. You draw a cross. The reason why you draw a cross because it tells you it's 40 degrees. So that means you measure 40 degrees from the north, right? You draw a cross 40 degrees. That's what the bearing means. 40 degrees from north, clockwise. For how long? 200 kilometers. And you get heading to Sydney. Oh, from Sydney. Okay, so this is from Sydney. Sorry. So we'll just write Sydney right then. Start. Okay, but you can leave it as start if you want. Okay, Sydney. It sails over there for 200 kilometers. Then sail on a bearing of 140 degrees, 157. Now, when you change direction, we have to draw a new cross. Every time there's a new direction, you draw a cross because that will tell you which direction you go. So this cross will be 157, which is over here, 157 degrees for longer for 345 km. And then you join this dot to the original, which is over here. You have to find how far is the ship from Sydney. X. So that's what we're trying to find. How far is the Sydney is the ship to the nearest kilometer. Okay, so what you need to do is to work out some angles in this triangle. So this is a very typical exam question. So the angle you can find is, use the fact that all north are parallel to each other. So we can find an angle. Now which angle can we find? Which is over here, alternate angle, right? That's 40. Alternate angles. Alternate to that 40 over there. Alternate angles on parallel lines, right? Alternate angles on parallel lines. Okay, so that's 40 there. But that's not the complete angle of a triangle. What's another angle we can find? 23, yep, very nice. So we're going to find this angle, which is this one here. So you can do 180 minus 157, which is 23. So find these two angles first. Why do we need these two angles? Because this will give me the big angle over here, the big one. The purple angle is just 40 plus 23, which is equal to 63 degrees. So I want to find that angle. The reason why I want to find that angle because now I could draw the triangle again because it looks confusing with all the angles given. So x here, that's the 200, that's the 345. So we get the angle over here, which is 63 degrees. So you might like to draw the triangle again so you can see what information is important, what information is not important. And we're going to find x. Okay, so now we're going to find the missing side. Now, think about what rule you're going to use to find x. What rule? It's S, A, S, which is cosine rule. Okay, we're going to use the cosine rule to find x. Okay, so try to do this now. Have a try. So use the cosine rule to find x. Alright, have a try. Use the cosine rule to find x. Okay, alright, so we start with x squared equals to 200 squared plus 345 squared minus 2 times 200 times 345 cos of 63 degrees. And then press the button on your calculator. So the button will be 200 squared plus 345 squared minus 2 times 200 times 345 cos 63. Press equal, give you a very big answer, 96374 dot dot dot. And then to find x, you have to square root it, correct to the nearest kilometer. Nearest kilometers will be about 310 kilometers. Alright, any questions? So it's pretty easy. And the question doesn't finish there. Usually they ask you to find another angle or a bearing after this. So you ask, what is the bearing of the ship from Sydney to the nearest degree? Okay, so again, you need to use the information you found in this question to do part B. What is the bearing of the ship from Sydney? So you need to know which angle you have to find. So let's look at it again. Bearing of the ship, let's use a red pen. Bearing of the ship from Sydney. So from Sydney is you draw across at Sydney. That's where you're standing. And that's where the ship is. So you have to find this angle. The angle you have to turn before you see the ship. So to find this angle, that means you have to find this small angle first, which is over here. Let's find theta first. Okay? Like how do we find theta now? Keeping in mind that x is now 310, what rule would you use? Sine rule. Okay, sine rule is quicker. You can use cosine rule, but sine rule will be much quicker. So we're going to write sine theta over 345. So sine theta over the side opposite to the angle theta. pick another side. I will pick the 200 because this is, actually I can't. I have to pick 310 because I only have the 63. So 300 sine 63 over 310. And then you can work out theta. So you do sine 63 times by 345 over 310. Use your calculator, which is over here. Sine 63 close bracket times 345 divided by 310, 0.9916, 0.9916, dot dot dot. To find the angle, you have to remember to do shift sine answer equal nearest degree, so about 83 degrees, right? So approximately, so that's sine inverse of 0.9916 dot dot dot, which is about 80. Let's read it again. 83 degrees. So 82.57 dot dot dot, which is about 83 degrees to the nearest degree. But be careful, this is not your final answer. We have to answer the question because it says find the bearing. Let's go back to the diagram. What's the bearing? It starts from the north, right? So I found this angle, which is 83 degrees, right? But that's not the bearing. Bearing goes from here. So what do you have to do? You have to add the 40. Okay, so you write therefore bearing of ship from Sydney is 83 plus 40, which is 123 degrees. Done. Okay. Today's exercise is 6 point, is it 12? 6.12? Yeah, I think 6.12. Okay. Yep.